In this video, I will solve some problems of matrices. The basic problems like how to construct a matrix, how to find two matrices are equal or not, sum of two matrices, their subtraction, multiplication of matrices, etc. Since it is not possible to solve all the problems of NCERT book in whiteboard, so I am bound to make this video. If you like this video, then please let me know. I will make more videos on a regular basis. So number 1, construct a 3 by 4 matrix Aij, where Aij is equal to half into minus thrice I plus j whole mod, where Aij denotes the element of ith row and jth column. So it's a 3 by 4 matrix, that is there will be 3 row and 4 columns, so 12 elements are there. So value of I will range from 1 to 3 and value of j will range from 1 to 4. So we need to find out the value of a11, a12, a13, a14, etc. So first find out a11. So I is equal to 1 and j is equal to 1. Put I is equal to 1, minus 3 plus I, this is minus 2, mod plus 2 divided by 2, it is equal to 1. You can calculate these things in your mind. Now a12, that is the element of ith row and jth column. I first row and second column. So put I is equal to 1, minus 3 into 1 minus 3 plus 2 minus 1, take mod is 1, so a12 is equal to half. Find a13, put I is equal to 1, minus 3, j equal to 3, 3 minus 3 plus 3 0, 0 mod 0, 0 by 2 is 0. a14, the element of first row and fourth column, put I is equal to 1, minus 3 plus 4 plus 1, take mod half. Similarly a21, now second row first column, minus 6, for I is equal to, it is minus 6 plus 1, minus 5, take mod plus 5 by 2. a22, second row second column, again I is equal to, so minus 6 plus 2 minus 4, take mod plus 4 by 2, it is 2. a23, second row third column, so I is equal to minus 6 plus 3, minus 6 plus 3 minus 3, take mod plus 3 by 2, it is 3 by 2. And a324, second row fourth column, now I is equal to, I is equal to means minus 6 plus 4 minus 2, take mod plus 2 by 2, it is 1. And a31, now third row first column, so a is equal to 3, I is equal to 3, minus 3 into 3 minus 9 plus 1 minus 8, take mod plus 8 by 2, 4. a32, now I is equal to 3, minus 9 plus 2, 7, it is 7 by 2. See, after mod it becomes positive. a33, third row third column, minus 9 plus 3 minus 6, mod 6 by 2, 3. And 3 4, third row fourth column, minus 9 plus 4 minus 5, take mod plus 5 by 2. So we found all the elements of this matrix. Therefore the matrix Aij is equal to 1 half, 0, 1 by 2, 5 by 2, 2, 3 by 2, 1, 4, 7 by 2, 3, 5 by 2. Now it is second question. What are the possible orders of a matrix having 24 elements? So we know when I multiply the number of row and number of column, we get total number of elements in the matrix. So here 24 is the total number of elements. So we can write 24 is equal to 1 into 24, 2 into 12, 3 into 8, 4 into 6, 6 into 4, 8 into 3, and 24 into 1. So these are the 6 different, one, and I forgot to write one matrix. This is 12 into 2. So these are the 8 different ways I can write 24. So these are 8 different ways in which I can write the 24 elements in a row, in column arrangements. So there are 8 different orders of the matrix. Therefore the possible orders are 1 by 24, 2 by 12, 3 by 8, 4 by 6, 8 by 3, 12 by 2, and lastly 24 by 1. So you can write the matrix in 8 different ways. Now the question has second leg. What if it has 13 elements? Now when the matrix has 13 elements, so I can write 13 is equal to 13 into 1 or 1 into 13. So there are only 2 ways in which we can arrange these 13 elements, either in a row matrix or in a column matrix, because in this case it has only one column, so it will form a column matrix, and second case it is only one row, so it will form a row matrix. So there are only 2 possible ways, so only 2 possible orders, that is 13 into 1 and 1 into 13. Now it is number 3. Now we will use the condition of equal matrices. Find the values of x, y, z and w if the 2 matrices are said to be equal. We know 2 matrices are said to be equal if they have equal corresponding elements. Now since they are equal, so I can write that x thrice x minus y twice x plus z 3y minus w is equal to 3, 2, 4, 7. So we know for equal matrices they have equal corresponding elements. See, the first element, the first row and first column is equal to the first element and first column, this is 3. So x will be is equal to 3. Similarly thrice x minus y will be is equal to 2. Since x equal to 3, so I can write y is equal to 3 into 3 minus 2, that is it is 7. Now twice x plus z is equal to 4. Since x equal to 3, so I can write z equal to 4 minus 2 into 3, that is minus 2, and 3y minus w is equal to 7. So w is equal to 3 into y is equal to 7 minus 7, that is 21 minus 7, 14. So I can write x equal to 3, y is equal to 7, z equal to minus 2, and your w is equal to 14. So using equality of matrices you can evaluate the values of x, y, z and w. Now fourth question is find a plus b, a minus b, ab and ba whichever exists. See, these matrices A and B are of same order, they are of having order 2 by 2. So A plus B, A minus B both will exist. Similarly, AB and BA both will exist. So let's find out A plus B. This is 2 3 1 4 plus minus 1 3 6 2. We know, I have already told you in video lecture, when I find the addition of two matrices, the addition takes place among the corresponding elements. Here the 2 and minus 1 are the corresponding elements. So if I find their sum, what is 2 minus 1? It is 1. Now 3 and 3 are also corresponding elements. Find their sum, it is 6. 1 and 7, find their sum, it is 1 is 6, it is 7, and 4 and 2, it is 6. So when I find the addition, it takes place among the corresponding elements. Now find out the subtraction of A minus B. So 2 3 1 4 subtract minus 1 3 6 2. Again, when I subtract two matrices, it takes place among the corresponding elements. Now the corresponding elements are 2 and minus 1. If I subtract minus 1 from 2, you get 3. Similarly, subtract 3 from 3, it is 0. 1 minus 6, it is minus 5, and 4 minus 2, it is 2. So when I subtract two matrices, it takes place among the corresponding elements. So here A plus B and A minus B both exists. Now find out the product AB. See, when I multiply two matrices, the operation takes place among the row and column. That is the row of the first matrix and column of the second matrix. So multiply AB. So here A is the first matrix. So it will be 2 3 1 4 multiply 2 minus 1 3 6 2. So when I multiply two matrices, the operation takes place among the corresponding elements. So see here, row 2 3 are the elements of first row and minus 1 6 are the elements of first column. So 2 into minus 1, it is minus 2, plus 3 into 6, it is 18. Similarly, 2 into 3, it is 6, and 3 into 2, it is again 6. So first row, first column, first row, second column. Now second row, first column. 1 into minus 1, it is minus 1, and 4 into 6, it is 24. 1 into 3, it is 3, and 4 into 2, it is 8. Minus 2 plus 18, it is 16. 6 plus 6, 12. Minus 1 plus 24, 23. And 3 plus 8, it is 11. So when I multiply two matrices, the operation takes place among the corresponding elements. Now you need to find out the product BA. How to find BA? To find BA, here B is the first matrix, so minus 1 3 6 2 multiplied by 2 3 1 4. Again, when I multiply two matrices, the operation takes place among the first row and the columns of the first matrix and second matrix. Here the first row is minus 1 3 and the first column is 2 1. So multiply minus 1 into plus 2. So it is minus 2. Then plus 3 into 1, it is 3. Minus 1 into 3, it is minus 3. And 3 into 4, it is 12. Now second row, first column. 6 2s are 12. 2 into 1, it is 2. 6 into 3, 18. 2 into 4, it is 8. So your result will be 1 9 14 and 26. Clearly you can see that AB is not equal to BA. So we have already told you, in general AB is not equal to BA. Okay, so here AB and BA both exists, but AB and BA are not equal. So this is my number 1. I have added, subtracted, multiplied two matrices. This is second question. Again, find A plus B, A minus B, AB and BA, whichever exists. See here, A is a matrix of order 2 by 3. There are 2 row and 3 columns. So it's a matrix of order 2 by 3. And B is a matrix of order 3 by 2. It is 3 row and 2 columns. So it's there of different orders. So you can write A plus B and A minus B do not exist. So you cannot find A plus B and cannot find A minus B. Now let me find AB. How to find AB? 1 2 5 0 6 7 and your B is 3 6 7 8 9 5. Now you see your matrix A is of order 2 by 3 and matrix B of order 3 by 2. See, the number of rows of A and number of columns of A and number of rows of B are equal, 3 and 3. So AB will exist and the result product AB will be of the order 2 by 2. I have already told you when two matrices are multiplied, then they are said to be multiplicative if the number of columns of the first matrix is equal to number of rows of the second matrix. Here the number of columns of A is equal to 3 and number of rows of B is equal to 3. So they are equal, so the product AB will exist. Now when I multiply two matrices, the operation takes place among the corresponding first row and the corresponding first column. Similarly, corresponding first row, corresponding second column. So 125 multiplied with 379. So 1 into 3 it is 3, 2 into 7 it is 14, 5 into 9 it is again 45. Now first row second column, 1 into 6 it is 6, 2 into 8 it is 16, 5 into 5 25, 0 into 3 it is 0, 6 into 7 42, 7 9 just 63, 0 into 6 0, 6 into 8 48, 7 into 5 35. So whenever we multiply two matrix, the operation takes place among the corresponding elements and the first corresponding row and column. So 3 plus 14 it is 17 plus 45 it is 62. 6 plus 16 plus 25 this is 22 plus 25 47. 42 plus 63 it is 105. 48 plus 35 it is 83, I guess. Yes, so the product AB exists. Now find out the product BA. Now the B is the first matrix, so it is 3 by 3 6 7 8 9 5. The matrix B having order 3 by 2 and matrix A is 1 2 5 0 6 7. Matrix A having order 2 by 3. Again, the number of columns of B is equal to number of rows of A. So the product BA will exist. The product BA will exist. Again, multiply row into column, 3 into 1 3, 6 into 0 it is 0, 3 into 2 it is 6, 6 into 6 it is 36, 3 into 5 15, 6 into 7 it is 42, 7 into 1 it is 7, 8 into 0 0, 7 into 2 14, 6 into 8 48, 7 into 5 35, 8 into 7 56, 9 into 1 9, 5 into 0 5 0, 9 into 2 18, 5 into 6 30, 9 into 5 45 and 5 into 7 it is 35. So upon calculation you'll get 3, 7, 9, 42, this is 62, then 48, then 57, then 91, and lastly it is 80. So the product AB and BA both exist, but AB is not equal to BA. Now we will use the property of multiplication by a non-zero constant k. Here you are given A and B two matrices of order 2 by 2. So find twice A plus thrice B. So 2 into A plus thrice B will be is equal to 2 into 1 1 1 1 plus 3 into B 2 minus 1 0 1 2 2 2 2 6 minus 3 0 3. Now find their sum. 2 plus 6 will be 8, 2 minus 3 minus 1, 2 plus 0 is 0, and 2 plus 3 is 5. So when I multiplying by a non-zero constant k, it gets multiplied inside to all the elements of the matrix. So 2 gets multiplied inside. This is 2 2 2 2, 3 into 2 6, 3 into minus 1 minus 3, 0 into 3 0, and 3 into 1 it is 3. So after that we'll add the matrices as they are of same order, so you can add them or you can subtract them. So it is now 8 minus 1 0 5. Now number 6, find the matrices A and B if A plus twice B is equal to 1 2 0 6 minus 3 3 and minus 5 3 1, and twice A minus B is equal to 2 minus 1 5, 2 minus 1 6, and 0 1 2. So you need to find out the values of the matrix A and matrix B. So how to solve it? See, here it is twice B, it is minus B. So we'll write A plus twice B is equal to 1 2 0 6 minus 3 3 minus 5 3 1, and twice A minus B is equal to 2 minus 1 6, 2 minus 1, this is 5, this is 6, and 0 1 2. If I multiply here by the constant 2, it is 2 to the 4A, this is minus twice B, and I'll multiply the matrix by the constant 2. I know when I multiply the matrix by a non-zero constant k, it gets multiplied inside. So it will become 2 to the 4 minus 2 10, 4 minus 2 12, 0 to 4. So this is my number 1 equation, this is my number 2 equation. If I add 1 and 2, adding 1 and 2 will get A plus twice B 4A minus twice B. So 1 2 0 6 minus 3 3 minus 5 3 1 added to 4 minus 2 10, 4 minus 2 12, and 0 to 4. So you're getting twice B cancel, 4A plus A, it is 5 times A. So 1 plus 4 it is 5, 2 minus 2 it is 0, 0 plus 10 it is 10, 6 plus 4 10, minus 3 plus 2 minus 5, minus 3 minus 2 minus 5, 3 plus 12 it is 15, minus 5 plus 0 minus 5, 3 plus 2 it is again 5, and 1 plus 4 it is again 5. So your A is equal to 1 by 5. See, we need to find the value of A, so I have divided by the constant 5. It is 5 0 10, 10 minus 5 15, minus 5 5 5. Now we are multiplying by a non-zero constant 1 by 5. so it will get multiplied inside. So your result will be 102, 2 minus 1 3, minus 1 1 1. Now I will replace the value of a here. From 1 we can say that twice b is equal to 1 2 0 6 minus 3 3 minus 5 3 1. A is equal to 1 0 2, 2 minus 1 3 minus 1 1 1. So 1 minus 1 it is 0, 2 minus 0 it is 2, 0 minus 2 it is minus 2, 6 minus 2 it is 4, minus 3 minus 1 minus 2, 3 minus 3 is 0, and minus 5 minus 1 it is minus 4, 3 minus 1 2, and 1 minus 1 0. So you are getting the value of b. How to find b then? Now divide by 2, you will get 0 by 2 0, 1 minus 1, 2 minus 1 0, minus 2 1 0. So we have evaluated the value of a and b respectively.